This video is going to be about um, inequalities. So just the basics of inequalities. So first, in symbolic methods, this one right here is x is greater than 5. You would say that as x is greater than 5. So what does that mean? Well, it means x could be any number that is greater than 5. So if I were to, excuse me, if I were to draw a number line, here's my number line. All right, I'll put 4 here, I'll put 5 there, and I'll put 6 there. All right, x is any number that's greater than 5. So what we do is we want to graphically represent all the possible answers. So we put an open circle at 5. So open circle meaning that 5 is not a solution to this inequality. 5 is not greater than 5. And then we would shade it to the right to show all the numbers to the right of that open circle are a solution. They are true. Um, they are all the numbers that are greater than 5. A lot of times you ask somebody, well, what are the numbers, if x is greater than 5, what must x be? And some students will say, well, it's 6 or more, when that's not true. What about right here? 5.1, or even closer, 5.01. All right, so when you say x is greater than 5, you show it graphically by drawing a number line, putting an open circle at 5, and shading to the right. Those are all the numbers that are greater than 5. Next one is x is less than 5. X is less than 5. Same thing, same number line as before. Okay, I'll put 4 here, 5, and 6. All right, open circle, because 5 is not part of the solution set. And we would shade to the left because this is all, well, that scared me, because this is all the possible numbers that are less than 5. Now you get to this one. This is read as x is greater than or equal to 5. So x is greater than or equal to 5. So if I were to draw the same number line, 4, 5, and 6, well, now 5 is part of the solution. So instead of an open circle, we put in a shaded circle to show that 5 is included. For example, not for example, but 5 is greater than or equal to 5. So, but where that's equal to, so where are the numbers that are greater than? They're to the right of 5. So once again, this is probably the most important thing to get from this entire video, is the shaded region represents all the possible values that make this inequality true. All right. Let's try the next one. X is less than or equal to 5. So x is less than or equal to 5. Shade, excuse me, make a number line 4, 5, and 6. We would put a shaded circle at 5 because 5 is part of the solution to this inequality. 5 is less than or equal to 5. But then we have to also include all the numbers that are less than 5. So we'd shade the number line in this direction. A lot of tones coming up today while I'm making videos. So all the shaded numbers to the left of 5 are also less than or equal to 5. All right, so let's look at some examples here. Inequality from graph. So here we have an open circle at -1, and we have all of these values to the right. So x and -1, well, x is all the values to the right of -1, so x is bigger than -1, and because it's an open circle, it's not included. So the answer is x is greater than -1. Next one, we have a shaded circle at 3. So I'll put x here. I'll put, excuse me, not 3, -3. All right. Now x is all the values to the left of -3. So left means less than. So x is less than -3. But remember, it's shaded in, so we have to include -3 as part of our solution set. So x is less than or equal to -3 is that value right there. I think we have one more. This is shaded circle at 1 and shaded to the right. So if I put x here and 1 there, well, we know that x is all the values bigger than 1, so x has to be greater than 1, but it also includes 1 because it's shaded in, so x is greater than or equal to 1, which is that value right there. I believe that's the last one. Yep, we're going to do the next one right about now. So, hope you enjoyed the video.